So, as you can see, today we're going to be doing some more solving of quadratics. Today we're going to learn a new technique besides factoring called square rooting or isolating x. So, as you can probably guess, our I can't statement is going to be solve quadratics by square rooting because sometimes we cannot factor. What just opened? Steam. And if you don't believe me, just take a minute, try to factor this problem. Remember our first steps, we always want to get it by itself. So we'll actually try to factor this together. So we'll have 2x squared, 8 minus 9, so 8 minus 9, so minusing 13 from both sides, we'll get minus 5 equals 0. So when we try to set up our thing, we'll need, so 2 times negative 5, so we'll need factor negative 5, that add up. You know, our middle term is 0 now, because if we remember our standard form is y equals ax squared plus bx plus c. Our middle term doesn't exist, so that means it's 0. We need 2 factors that add to, or multiply to negative 5, but add to 0. Nothing times itself equals 10. So what we're going to do instead, well, our goal for this, our answer is actually negative 5 over 2. Will do. So our end goal would be to get, our final answer would be x equals plus or minus negative 5, or plus or minus square root of 5 over 2. How do we get that? Well, we do a fancy new step. We're used to getting everything onto one side, but instead we're going to try to, as it's stated in our title, isolate our x. So we have the function 2x squared. What we're actually going to do is add 8 to both sides. If I could stop scrolling. Sorry, subtract 8 from both sides if it's positive. So we'll have 2x squared equals positive 5. If we want x by itself, so we'll divide both sides by 2. Gives us x squared equals 5 over 2. Now last step is going to be taking the square root, as it said in our title. So what this does is it gives us x equals the square root of 5 over 2. But if you remember when we're taking parabolas, or when we had parabolas, most of our zeros are actually, we have 2 zeros. And because of this method, our answer is actually plus or minus square root of 5 over 2, or this also means x equals square root of 5 over 2 and negative square root of 5 over 2. The reason that is because x could be positive or negative, because when we square it, it doesn't matter what happens to it. Because negative 1 squared still equals 1, and positive 1 squared still equals positive 1. Same thing if we did 2. 2 squared equals 4. Negative 2 squared still equals positive 4. So when we take the square root, we need to take that into account by making sure we have both positive and negatives as our roots. So with that basic premise out, we're going to just be doing some examples. So similar to our first one, we're going to subtract 1 to get 2x by itself. Positive 8. And we'll divide both sides by 2. So we'll have x squared equals 4. And then our last step, take the square root. And remember that it is x equals plus or minus the square root. Square root of 4 is 2. You will have a calculator available to you for any testing or whatnot, so you don't have to know all of your square roots and squares. So we're just going to keep her going. So 3x squared. Our first step here is going to be adding 4 to both sides. So 3x squared equals 27. We divide both sides by 3 to get x squared by itself. We get 3x equals 9. When we take the square root, we get x squared equals plus or minus 3. You do need to remember the plus or minus 3. Just giving me that, or just giving me the minus, is only one part of the answer. It's only half the answer. So we're actually going to just blow right through these problems. So we'll have 2x squared. We'll minus 1 from both sides. We'll get 2x squared equals 18. We'll divide both sides by 2. We'll get x squared equals 9. And just like before, we get x equals plus or minus 3. Over here, we'll have negative 5x squared. We're going to subtract 3 from both sides. That's going to give us negative 12. Divide both sides by negative 5. So we'll get x squared over 12 fifths. And then we take the square root. We do not have to simplify our rational, we don't have, what am I trying to say? We don't have to simplify these any further than what they are. You don't need the decimal form, you can just leave them in the form that they're in. So our answer would be x equals plus or minus the square root of 12 over 5. If it can't simplify, simplify it. If it can't, just leave it as it is. So another form that we're going to see is if we have the same thing multiplied by itself. And we do that the exact same way. So what our first step here, normally we want to get x by itself, so we have to get everything in the square root by itself. So our first step here is actually going to be multiplying both sides by 3. So we'll have x plus 5 squared equals 21. And then we take our square root, because that's our only thing that we can do. So we'll have x plus 5 equals plus or minus root 21. Actually. Yeah. So, and then our last step is going to be subtracting 5 from both sides. So we'll have x equals negative 5 plus or minus the square root of 21. Similar thing here, except we're going to start with dividing 3 from both sides. So we'll get x minus 2 squared equals 7. We take the square root. We'll get x minus 2 equals plus or minus square root of 7. And then we add 2 to both sides. So we get x equals 2 plus or minus the square root of 7. You'll notice this plus or minus stays with the square root. It doesn't follow up with the minus sign, or the negative 5, or the positive 2. And just my review, first thing, we're going to add 6 to both sides. Get 4x squared equals 48. Divide both sides by 4. X squared equals 12. Square root. We'll have x equals plus or minus square root of 12. And what should be our final practice problem, multiply both sides by 5. We get x minus 4 squared equals 30. Take the square root. Everything under the square root gets left, so we get x minus 4 equals plus or minus 30. And I can't scroll anymore because we're at the bottom of the page. So then we add 4 to both sides, and we get x equals 4 plus or minus square root of 30 as our zeros. And that's about it. You guys have your practice. It's a real short lesson today. We're just going over this one property. If you have any questions or need help with anything, let me know. I'll be right over.